Hey, welcome to Math from Inside channel. Here we make mathematics easy and understandable for all. So today we're trying to find the arc-length formula, and then we will apply that arc-length to find the arc of the function of this function from going from x equal to 0 to x equal to 3. So we will do these two problems in two videos. The first video will be dedicated to find the arc-length formula, and then we'll have a second video just to do the application with this function. So let's go. So in figure 1, we can see that we have a curve C. We have the curve C in blue defined by the equation y equal to fx, f of x. And we can see that f is continuous in the interval AB. So if we break the interval AB into n subinterval, then, or of course, if we break the interval AB into n subinterval with the endpoint x0 equal to a, x1, x2, to xn equal to b, with those interval having the same length or the same width called delta x, then we can say that the polygon P0, P1, P2 to Pn, which is in red, is actually an approximation of our curve C. Now, when the more interval, the more subinterval we have, the closer our polygon is to the curve C, as we can see in the figure 2. We can see that below here we have 4 subinterval which make the polygon closer to the curve C compared to the third one, compared to the second one, and compared to the first one. Okay, so now if that's the case, it means that the length of our of our polygon when n goes to infinity, n equal to the number of subinterval, is actually equal to the length of our curve. So how can we write that in the mathematical way? We can just say that L, which is the length of our curve, is equal to the limit when n goes to infinity, plus infinity of course, of the length of the polygon. But what's the length of the polygon? It's actually the length of all the segments. The length of P0, P1 plus P1, P2 till Pn minus 1 Pn. So we can write this as the summation when I goes to 1 till n of Pi minus 1 Pi. Of course, given that we have Pi with the coordinate xi, yi, and we have yi, of course, will be equal to f of xi, because Pi belongs to our curve. Now, but how can we find this distance? Pi minus 1 Pi. If you consider this triangle rectangle, we can apply the Pythagoras theorem. Here we say that Pi minus 1 Pi square is equal to what? It's equal to delta y square plus delta x square. Now, we also have to consider something. If you apply the mean value theorem to the function f in the interval x minus 1 xi, so we will, of course, because f is continuous also there, so we will find, so there will exist a number, a number x star I that belong to, of course, that belong to our interval xi minus 1 xi, such that f of x I minus f of xi minus 1 will be equal to f of x star I, or I star of xi minus f of x minus 1. Now, we did not say it, but delta yi is actually equal to f of xi minus f of xi minus 1. So we can write this expression as, this can also be equivalent to delta yi equal to f of x star I of delta x. Time delta x. So what can we do here now? We can replace now this expression into this one. So let's say this one was 1 and this one was 2. So we can replace 2 into 1. If we replace that, we'll have p I minus 1 pi square equal to f. Oh, this is f prime. I'm sorry, this is f prime. So f prime x I star square delta x square plus delta x square. And if I factorize it, I will have delta x square 1 plus times 1 plus f prime of x I star square. So it means that pi minus 1 pi itself will be equal to the square root of 1 plus f prime of xi star square, this time delta x. And we name this expression 3. Now we can name this one as a, expression a. So if we replace 3 into a, what do we get? We will get L equal to the limit when n goes to infinity of summation of when I go from 1 to n of square root of 1 plus f prime of xi star all square times delta x. And when n goes to infinity, this series will converge to what? Will converge to the integral when from a to b of square root of 1 plus f prime of x square dx. And that's how we do to find the arc length formula. So if you have any comment, please write it. And if there's something that you want to understand better, let us know. So we'll have a second video where we actually go and apply this formula. See you soon.